9.0 back in September 2019. First patches, so I think it was mentioned at the intro, I kind of initiated that upstream risk-side RVM effort. I started to work on that a bit before October 2017, a few months to get the initial series of patches up and running. And then it took about 2 years or so from then to go from being something that wasn't turned on by default to something where we did a whole bunch of wide-scale testing and were able to demonstrate that it could build a large corpus of, say, user-space applications or spec TTC torch suites and so on. I've lost my idea, so I don't have to hear it, and that's fine for me, I guess, what's going on. In terms of another aspect to mention is that you no longer have to rely on talk from people like me to see which RISC-V biotech extensions are actually supported within LVM. This doesn't mean to do a particularly good job out before, in that there weren't any documentation, perhaps quite weak point. I'll advertise this URL a few times within the talk if you want to go to see exactly which extensions we implement and whether it's just at the assembly level or the coding as well. We've got a kind of up-to-date listing there. With Providence, it's been a while since one of these updates, so this is particularly new news, but for a long time, the LVM linker was somewhat behind the Gideon's linker in terms of support for linker relaxation. This is a transformation that you might recognize we rely on quite a lot in RISC-V. We have a relatively short, immediate within our instructions, so just 12 bits, plus obviously separate instructions for 20 bits, which means that most commonly you end up requiring a pair of instructions on memory access operations. The linker can then go and often delete one of those instructions if it turns out that actually you put those high bits or you. So what I did was have a look at comparison of what we support versus the recently agreed RISC-V 64-bit profile. This is a really good way in which we've gone about developing these extensions, but it kind of coincides with this extension that people are interested in. So for everything we've recently ratified, for everything in the currently proposed, but not ratified RVA22 proposal, we have support. So CodeGen, the only one that's kind of missing is the ZICC LSM, which was very pleased to see it in that in the profile specification. That's always indicating that the core supports misaligned vector stores, which we didn't previously support in the ISA naming string, which is a nightmare for the compiler, because although as an end user you can rely on the fact that misaligned vector stores will be handled by a trap manager and everything else, but the compiler you don't know that someone's compiling for a context where the trap handler would be acceptable, say, a program that's going on or something. So the support for coding there is a kind of point to take because we do need to have a command line flag to support that is how it up to that particular namespace. Looking ahead to what's currently proposed with RVA 23, so I've not listed things again that were already in the previous one. Again, we're in pretty good shape. The bits that are missing or slightly work in progress would be so BFlow 16. I've been working on finished RVM layer support. I've also been working on the CodeGen for that on the SCADA side. There's been some recent discussions with the broader community around whether the S16 type should be a storage only or storage and arithmetic type, despite the fact that many architectures support all arithmetic operations, which is largely resolved. The Z-icon, which is roughly what used to be the decline additional operations, we have established CodeGen support for that. There's still work that I'm aiming to do to. Basically, there are a number of slightly heroic optimizations that LVM does where you can generate a branching sequence of instructions in the base instruction set. And once you enable that icon, occasionally that branching sequence of the base instruction set will be better. So there's a bit of tuning to make sure that we never regress on those workloads. And we have the big one where we're kind of waiting for more standardization is around the vector crypto, where I think it's likely to be intrinsic to this block. Now, I'm talking about this as what I see it as a real success story for cross-community collaboration on an upstream project. And we kind of started from a point where there was lots of downstream work, research support that wasn't quite ready for upstreaming, lots of people modifying that to solve our immediate needs. struggle to get over that hump of getting people actually working together upstream. And of course, it makes sense to work together upstream because almost everybody in this room isn't trying to differentiate based on a proprietary compiler. Customers, for the most part, aren't particularly excited about tool chains that they're not able to support themselves or modify. The first contract work that I had in doing LDM stuff on this side was from one of the semiconductor firms interested in getting involved in this side who were concerned that A, there was this blocker with people, everybody waiting for somebody else to do the work, but B, that perhaps those who were producing this side IP might have a bit of incentive to be the one who had the best downstream compiler when actually the global optimum would be to have something that's upstream to share for all contributing to. And full disclaimer for everything in this talk, I've done a whole lot of work on this side of LDM over a number of years, but it's a huge number of contributors by now. This is a very incomplete list of people who've been contributing in terms of code, reviews, advice. I think just under 100 people, but adding in the people who I certainly most easily over 100. So it's been a huge group project. But another proviso of this slide is that I don't want to look at this and think, there's a small number of people already working on this side of LDM, there's nothing wrong with contributing. This is, out of many open source projects, there's a small core of people who are perhaps doing most of the ongoing day-to-day work. But what it's demonstrating is working really well is that open source aspect where someone sees something's broken, they're able to come in, produce a patch, get it committed, and move on. I think this is demonstrating that aspect is really working well. So in terms, it's roughly 4,500 commit and roughly 56,000 lines of code just focusing on the LDM backend part, more lines of code spread throughout the rest of the LDM repo, and of course many more in tests and such. And how we actually work on this, it may surprise some people who perhaps haven't followed LDM before. There's no top-level LDM committee who agree what features are on the roadmap, what's going to be in the next release of LDM as a whole. As a whole, it's purely time-based. Each company contributing to LDM manages their own engineers, decides which things report to them. If it gets in, it gets agreed by consensus before it's branched, then it's good, and if not, then it will make it into the next release. And so that's how prioritization works in that context. It'll be really interesting with, we've had lots of talks talking about RISE, that should provide a good forum for multiple companies with resources to contribute within the LDM ecosystem to do that kind of prioritization that perhaps would be going on at other firms like Farm, Intel, and almost everything about the collaboration in this is actually all upstream using the standard community methodologies. So there isn't a LDM working group within this Farm International because that wouldn't make sense. There's an existing collaboration process. It would be wrong, I come across somewhat rude if a bunch of people in a separate organisation haven't LDM what to do. So if there's a change that might be controversial or might be disruptive perhaps to others in the ecosystem, we'll go through the standard RC process. The discussion takes place on the upstream LDM mailing list, or move to discourse forums. We make heavy use of pre-commit review and use of code systems. Technically, the code after this LDM having started in the initial offer, but these days there's probably 3 or 4 of us in doing the bulk of last level reviews. A big piece of this also has been bi-weekly sync-ups or coordination, which is used quite a lot within LDM, and we found it incredibly helpful for helping to unlock patches because of theirs. We all know with code review there's some kind of feedback where it's really helpful, but other things where it's a bit more of a design question, you can just get stuck in a very long comment thread that somebody goes on. So just getting people together on a call and figuring out, is it actually option A or option B we want, or is it a better one, and then going away and reworking things is really helpful. So that's, I said bi-weekly here because I always call it fortnightly if everybody else thinks that's, people have people who aren't really think I'm just making up the word, but that takes place every other Thursday, so I think I have an explanation on this in the slide. But it's not just upstream within LDM, there's obviously a lot of overlap with RISC-V standards and also with GCC importantly. It's very important to us that if GCC and client were trying to roughly the same feature, it would be kind of unfortunate for everybody if we had an arbitrarily different way specifying that by a landline flag. So that's where things like RISC-V toolchain conventions really comes in. We're trying to coordinate that work with GCC. That one's relatively informal. It's basically just us developers discussing and trying to find consensus. Some that's rather more formalized would be the PSABIs that we call convention, a lot of details of the ABI, where there is a risk-life working group, and Keaton and Jessica have done a really fantastic job of leading forwards. And of course, we rely on the ISA spec and other things such as around assembly designs and those kind of things. Another important aspect is how we handle not yet rationalized administrative extensions. I said on the previous slide that we're just trying to integrate with the native standard upstream LLM development process. But this is the case where there's gaps because RISC-V isn't quite like other architectures in this respect. If you have a new ISA extension for ARM, let's compare RISC-V vector extension versus ARM's SE. Obviously, lots of people had access to XE beforehand, but once it was public, that was the first time that the public upstream LLM saw the spec and initial patches implemented. We don't have that restriction within LLM, within RISC-V rather. All the work on extensions is going on in the public, and we would be missing opportunities to get things, collaborate on a shared repository if we didn't try and take advantage of that. So that's why we worked through an agreement that we can merge support for standard extensions that aren't yet ratified behind the experimental flag. However, there's no backwards compatibility guarantee, there's no move from 0.13 to 0.14. 0.13 is one, we're not going to support that again, and then we'll only support the final ratified version. This means that we can actually work together upstream. And of course, an aspect of this is the usual code review standards apply. It's not we commit it and then fix it later. The usual rigorous, making sure that it does the right thing in the right way with all advice. Another bit I just wanted to highlight is that vendor extensions we also fully supported. We've had a number already upstream. There's more of a framework, I suppose, for deciding when it makes sense to support upstream. There's more of a discussion around what the burden will be on the upstream community, how people going to support